Look at that. Mr. Bierschbach can record again. So I can actually record the lectures now. Got a different computer. One that actually can record. And I can walk around and talk into the computer. I can stand right by you and talk, and it'll pick it up. Yeah, you'll be on the video now. All right. So what we're doing in chapter 3 is proving trigonometric identities and working with trigonometric identities. And if you're going to take AP Calc, this is a hugely important chapter for you. All right. So if you're going to take calculus at college by chance, it might be kind of important for you. So what we're doing is we're trying to figure out how to make this equal to 0. Does that look very equal to 0? Not really. So, what do you think cotangent's the same as? Cotangent is what over what as trig functions? Do you remember from earlier this year? Cotangent is adjacent over opposite, but we have to talk about it in terms of sines and cosines. What do you think cotangent is? Is it sine over cosine or cosine over sine? Cosine over sine. So what we will do is put this as cosine of x over sine of x times sine of x minus cosine squared of x times secant of x is the reciprocal of what trig function? Secant is the reciprocal of what? Cosine. So it's 1 over cosine of x. So what happens over here is, see how I have sine in the denominator and sine in the numerator. What can you have when you have multiplication, you have a sine over a sine? Cancel to be just cosine of x. And here I have cosine squared in my numerator over cosine in my denominator. Well, there's two because cosine squared is really cosine of x times cosine of x, right? So I can take one of these cosines of x and cancel with that cosine of x, and I get cosine of x. What's cosine of x minus cosine of x? Well, that's 0. So I just proved that 0 equals 0. This is what we're going to do a couple weeks from now. We're going to be doing a lot of this. We'll maybe start it, the end of next week. But we're not going to worry about this quite yet. But what we're going to do now is get your note cards ready. So you will have a note card in here. Write small because there's a lot that goes. I don't have to tell you to write small. That's just a given fact. But write small because there's a lot that goes on these note cards. Oh, you've already got yours. All right, so make a section called Basic Identities. Label it Basic Identities and write down those 8 things, please. Basic identities. And write down that the cosecant of x is equal to 1 over the sine of x. The secant of x is equal to 1 over cosine of x. The sine of x is 1 over cosecant. And the cosine is 1 over secant. And those 4 tangent and cotangents.
I still want a note card. That was the one that was stuck in my book.
Nope. Right. To your right. Up a shelf. The OCD in you is just so funny. Yeah, I know you need a drink on. I get you. Yes.
I think anyone. Someone actually always did this.
What the heck are you doing?
Yeah, I know. I feel like we did like no. Oh. Yeah, true.
Okay, how are we doing with these? The next section is going to be called Pythagorean identities. So that'll be another section on your note card. Okay, so our Pythagorean identities are sine squared plus cosine squared equals 1, secant squared plus tangent squared equals 1, and cosecant squared equals cotangent squared plus 1.
No, I'm not.
Then after our Pythagorean identities comes our odd and even functions.
He's reading this.
So our odd functions, the sine of negative x equals negative sine of x. The cosecant of negative x equals negative cosecant of x. The tangent of negative x equals negative tangent of x. And the cotangent of negative x equals negative cotangent of x. And our last ones today are our even functions. The cosine of negative x equals positive cosine of x. And the secant of negative x equals positive secant of x. Okay, so the next stuff doesn't go on your note card. The next stuff I'm about to put on the board. So make sure you get this stuff down. Mia, you good back there? Okay. All right. So I'm going to show you what we're going to do in the first half of today. Okay? The first half of today, what we're doing is we're changing things in terms of sines and cosines and simplifying them. Okay? Because sine and cosine are our basic functions. If we can turn things into sines and cosines, then we can manipulate them the way we need to. So from our note card, what is cosecant of x equal to? 1 over sine of x. And what is cotangent equal to? It's 1 over tangent, but that's not in terms of sines and cosines. There's one that turns it into sines and cosines. It's cosine of x over sine of x. Now, from algebra 2, we've got a fraction with fractions in it, so we call that a complex fraction. How do we get rid of complex fractions? You can either multiply by the reciprocal of the denominator or multiply by the denominator of the denominator. We'll just multiply by the denominator, both on top and the bottom. So if we multiply both of them by sine of x, what happens is the sine of x's cancel, and I get 1 over the cosine of x. And that's how we'll leave it for today. We won't change that back into the secant of x, even though 1 over cosine is the secant of x. This is simplified in terms of sines and cosines. So it's just 1 over cosine of x. Okay? So I took cosecant and cotangent and made it into 1 over cosine. The next one. All right. I have 1 over cosine squared of x minus 1 over cotangent squared of x. Do they have a common denominator? No, I can't add or subtract fractions until I have a common denominator. Now the first one's already in terms of cosine. 1 over cosine squared is in terms of cosine. The second one is not. Cotangent squared is what over what? Well, what is cotangent? Cotangent equals 1 over tangent, or it's equal to what over what? Basic identities. It's cosine over sine. So if it's cotangent squared, it's going to be cosine squared of x over sine squared of x. Uh-oh, got another one of those dang complex fractions there. How do I get rid of a complex fraction? Multiply by the denominator of the denominator. Multiplied by sine squared of x on the top and the bottom. So then that becomes 1 over cosine squared of x minus sine squared of x, and these cancel, over cosine squared of x. All right. So now do I have a common denominator? Yeah. So I just subtract. So I go 1 minus sine squared of x over cosine squared of x. And you think, okay, I'm done. Not quite. Here's where we introduce the subject of Pythagorean identities. Our first Pythagorean identity is sine squared of x plus cosine squared of x equals 1, right? Sine squared of x plus cosine squared of x equals 1. Now, is there any way I can turn this equation to make it look like this? Something from here to make it look like this. What would I do? Subtract sine squared of x from each side. So then those cancel to be cosine squared of x equals 1 minus sine squared of x, correct? Well, then I use this fact to replace 1 minus sine squared with cosine squared of x, which is equal to, what's cosine squared over cosine squared? 1. So I took this original function, and in the end, I was able to get 1 out of that. 1 over cosine squared of x minus 1 over cotangent squared of x is equal to 1. Okay? So, that's some of the stuff you'll be doing today. Now, let's look at this one. When you see something like that, what is a magic math word you think of? Yeah, the little 4-lettered F word, FOIL. Okay? So, let's FOIL this. 1 times 1 is 1. Outers is negative cosine of x. Inners is plus cosine of x. Last times last is minus cosine squared of x. What's negative cosine of x plus cosine of x? 0. They cancel. So the middle two terms cancel, and you get 1 minus cosine squared of x. Is that fully simplified? Well, if I ask that question, the answer is probably going to be no. Because remember, we have this Pythagorean identity, sine squared of x plus cosine squared of x equals 1. So how can I manipulate it to look like that? What would I do to this equation to make it look like this expression? Subtract cosine squared of x from each side. So sine squared of x equals 1 minus cosine squared of x. So 1 minus cosine squared of x equals sine squared of x. So this whole thing here, this binomial, multiplies to be that in the end. Amazing what we can do with trigonometry. Oh, we just got a little more complicated here. This is another FOIL problem, but before we FOIL, let's see if there's something I can do. I have sine, cotangent, cosine. Which one of those is the adduct there? Cotangent's the adduct. What's cotangent in terms of sines and cosines? What's cotangent in terms of sines and cosines? Cosine over sine. Well, what happens right here in this multiplication part? What can I do? Sines cancel, so I get cosine of beta plus 1 times cosine of beta minus 1. Well, now all I do is FOIL. Cosine squared of beta. Outers is minus cosine of beta. Inners is plus cosine of beta. Last times last is minus 1. What happens to my middle two terms? They cancel in this case. And cosine squared minus 1. Okay, this is not the same as the last problem, so be careful. Sine squared of x plus cosine squared of x equals 1. How do I make it look like cosine squared of x minus 1? Well, we have to subtract the 1 from each side. So sine squared of x plus cosine squared of x minus 1 equals 0. And then what do? I want just cosine squared of x minus 1, so I have to get rid of the sine squared, right? So I subtract sine squared of x from each side. So cosine squared of x minus 1 equals negative sine squared of x. So the answer is sine squared of beta, and it's negative. So that's what this whole thing simplified all the way down to be that. So your first of your two assignments today is 7 through 14 all, page 165. Leave them in your notebook, and after we do about 4 or 5 sections, then I'll come around and grade them. Okay, so there you go. That's what we're doing first. All right.